talk about the video data, whatever, we'll plot the special map, right? So the data can be from any field. We already talked about the changes of z as a function of xy, right? So if we want to see the changes of z as a function of x and y, so we need to draw like a map. So in geographic data or the spatial data, x is a longitude and y is a latitude. So for example, if you want to show the COVID-19 cases over Bangladesh or over globe, then you need to show the location. When you talk about the location, you need to show the longitude and latitude, okay? So longitude is from negative 180 to positive 180. That's mean this is a negative is a west, positive in the east, okay? And the latitude from 90° north to 90° south, okay? So the positive is north and negative is south. And we have the equator is 0, okay? So this is the equator. So any data, any data from any fields, if you want to show our geographic location, then you need to understand this map. So these are globes, this is our earth. So our earth is divided into different grids. You can see the grids. Can you see the figure?
Yes, sir.
So this is understanding. So we have a data, then we need to calculate about this grid. So with let land grid lines. So our globe is like that. Okay. So these are understanding. Then we'll talk about the geospatial map and how to plot the data. Say for example, from my field, if I want to show the rainfall over x and y, that means over longitude and latitude, then we need to plot the z value. Okay, so z can be rainfall, temperature, any data. Okay. So you have already installed the NetCDF4. This is a scientific data. NetCDF4, then Cartopy is like cartography. Python is for the geospatial analysis, for mapping. We also can use the XArray. Okay. So we need to import the NetCDF4 data set. We just want to know our data. Here you can see the data as a precipitation.nc. NC is a NetCDF data. So it's not like a text file or Excel or CSV file. You just click and it will open. No, you need to use different platforms, different apps to open this data, to know this data. You can use Linux, okay, you can use NCL, MATLAB, Python, R, whatever, in CDO. So you need to use a specific programming, okay? This is the binary data, so you can open it by clicking. So you need to know the data. That's how we just importing the NetCDF4 data set. Then we can also know the data by using the XArray. We can plot the matplot library. Okay, we need a NumPy if I want to mean or average the data. Then we will use the NetCDF from Science Python for plotting, like masking the data. We have a map, then we have a data. We will mask over data like what we do in GIS. Okay. Then we'll use the Cartopy CRS, like this is a cartography coordinate system. CRS means the coordinate system. Okay. So first we need to know our data, okay? I always say you need to know your data. So the data is your data set. We are using this function, and R means read. Our file name is precipitation.nc. Okay. Then for data we have a variables. Then this is like dictionary in Python. We have a keys and we have values. Okay, so we can see the sorry, I didn't import the library first. Okay. Now we know we have a geopotential like Gaussian geopotential height or lat, lon, time, PRC. This is a precipitation. We'll know more about it. So let's see the variable, right? Like we have GWGT is a like lat Gaussian waves. Then we have this no unit. We have a lat. This is a latitude. This is a degrees north, and the shape is 64. Okay. We have a lon. Lon is degrees east. Then 128. This is a shape. Then we have the time, year, month. Okay. And we have the final variable like PRC. What we need, this is a precipitation. Okay. The name is PRC. The data type is plot. The units is millimeter per day. We have a field value for the missing value, and shape is 216. Like we have a time 216. That means 18 years. This is a monthly data. Okay. Then 64 lat and 128 grid. Like what I said, this is a grid. Okay. This is a grid data. So how many grids there? Okay. Now we can also open by XArray. We can open our data set. We can see we have a lat, we have a long time, we have like PRC. So by XArray we can also open it. We need to know the minimum, then our variable is precipitation. Let's run and see. The precipitation units is millimeter per day, and we know the shape. Okay, hills now. So now we can handle it. Sorry, it's disturbing. So we can know the minimum value, maximum value. So we need to know this. And our lat is from -87 to 87. That means this is a global data. And lon is 0 to 357. That's it. If we convert it like lon is the middle central, then -180 to +180. Okay. These are global data. Then we can extract our lat, then lon, time, the precipitation. Okay. We are extracting our data. Then we want to mean our data. Because lat and lon, this is a 2-dimension, but we want to mean our precipitation data over time. We have a 3-dimension of data. We have time, we have lat, lon, right? So we are just averaging the time variable. Like the precipitation has 3 dimensions: time, lat, lon. So we are averaging the time. So the data will be only 2-dimension, like x and y, lat and lon. Like we can plot a map. Okay. That's why I use mean. These are mean rainfall. Okay. Now we can plot the contour F. I already showed you in the last class. Okay. We have x is a longitude, y is a latitude, and we have a data. This is a z, like x, y, z. Okay. Now we can make a map like this, like a plot figure, but we want to show the geographical location, like we want to use a shapefile. We want to show the area or the country or the globe. Okay, so that's why we need to use a Cartopy or XArray to mask data over shapefile, like what we do in ArcGIS. Okay, so we need to understand the transform and the projection keywords. I will not talk more about it. I just provided the link. You go and just know about the projection. If you want to analyze your data over different geographic locations, so you should have some basics of geography. Okay, from any field, you need to analyze your data over different countries or regions, whatever. Okay, so you just learn it. So from data set, now we'll use the NetCDF, okay, to mask. We want to mask and like scale our data, precipitation data. Then PRC, we just extracting data, but in this case, I'm just using 0. 0 means we have 216 time, right? Just I want to plot the first time. Even you can plot the mean data, but it should be 2 dimension, okay? That's why I'm just using 0. Then AX is a plot axis projection. The cartography coordinate system is plate carry. I provided the link, this projection list. You will go there. You go there, you just try to learn, okay? Just read it about this geography. So we are using the globe data. Then we can like mask over country, region, whatever, even you can plot over the globe, okay? So you need to read this documentation, okay? All right, then we want to make the contour F, X, Y, then Z. Our CMap is like, you can use different CMap, the color. You just type the CMap in Google, you will find the link and you'll just plot it. Then transform this cartography coordinate system is plate cartography, okay? Then we want to add the coastline, like in a map, and coast, okay? The coastline, like we have a land and we have ocean, okay? And for the coastline, we need to add the boundary. That's why we are just adding the coastline, okay? So then we want to also add the grid lines, like in ArcGIS we use the grid lines like latitude and longitude, okay? Let's run and see. So you see, this is a global map. We have plotted the rainfall, okay, over globe, and grid line for this, okay, the latitude and longitude, okay. But we want to modify, like we just want to keep the grid line for like x-axis and y-axis, like longitude and latitude. We don't want to keep in the top and right side, okay. For this, we need to add something, okay. Oh, another thing, like this is a global shapefile and we mask our data over globe. But if I just want to select our like country shape, like with country or over region, like if I just want to plot with this region, so how to do that? If you want to map over region, then you need to add like set underscore extend, okay? This is a regional map. In that case, you need to use the minimum lawn, minimum lat, maximum lat. So here I provide the longitude is 30 to 170 and latitude is negative 30 to positive 30. Just run it, you'll get, you see now you're getting over the region. You don't need to plot the whole globe, okay? Now we want to remove the grid lines from the top and the right side, okay? So in that case, we need to like define, okay, grid line exists, like grid line draw labels true, but top labels false and right labels false, okay? We want to add some extra features to the map. Like we want to add ocean, we want to add land, lakes, rivers, okay? We want to give like the boundary like different color, black. So for this, we need to import the cartography feature, okay? Cartopy feature. Then run and see. You see, we have added some like river, lake, etc., etc. And we remove the grid lines from the top side and the left side. Even we have added the color bar, okay? The color bar for the value, okay? These are like 28 millimeters rainfall is here, okay? In Australia, like here, okay? So by this way, we can modify our map. We can also open our data through the XArray. Even we can plot through XArray. Okay, like we have a data precipitation.nc, then we open data set through the XArray. PRC is a DS, like the data sets PRC. We are just opening the first time of the data. Okay, then X1 is X axis one plot, X is the same thing. We are like using the regional map, coastline, etc., etc. Same thing, just using the different library like XArray. Okay. We also added here like C bar. This is the color bar, but shrink and but it's like 0.8. Okay, the width. So we provide the title, like we kept empty title, then plot show. Now you can see the figure. We can also plot over XArray. This is the special mapping, like precipitation millimeter per day, 5 to 25 millimeters, showing this color. By this way you can plot. And I have also provided a link for a very good tutorial on spatial mapping. So this is all about the spatial mapping. Understanding is the key. If you have the data, then you just plot over lat and lon, like you have a geographical location. You need to just add the shapefile, like in ArcGIS we do manually, but in Python you don't need to do manually, just use the code. Okay, that's all about the spatial mapping. We have also the 4-dimension of data, like I already talked in ArcGIS. Okay, we have a 4-dimension data, 3-dimension data. You can open it, whatever. But finally, we plot over 2 dimensions. That's it. So, do you have any question? Hello. Hello, can you hear me?
Sir, there have a question in the chat box.
Yes, what is the question?
Sir, how do I convert hourly data in daily?
Hourly to, you can use a CDO. Who made this comment? Alright, let me show you. Okay, let me share YouTube. I have a tutorial. Hourly to daily, daily to monthly, monthly to yearly is very simple. Just use CDO. I'm a data operator. Time. I hope you can see my screen, right?
Yeah. Yes.
Sir, could you please share the material?
Of course, I will upload on YouTube. Just wait. I'm a data download and processing. This is a playlist. And here you'll find the climate data processing with CDO. Okay, just follow it. There is a command. There is a script, like just one line. You can convert it. Okay. Like here, say for example, you need to use a Linux. Okay. This is my data. Can you see my screen?
Yes.
Sorry, I'm using a lot of things. It's taking
Hmm.
time. I think I don't need to show here. You just follow this video. It's better. Okay. Likes. You need to first change the directory mnt. This is F. Oh. It's like proceed 260 16 times step, right? This is like saying the daily. So like in CDO, if you have hourly, just use hour mean, okay? Or if you have a daily data, like hourly to daily, just use day mean. That's it. Then the file name and the output file name. That's it. It will be like if it is daily mean, then I can use the year mean. Year mean precision. I'm giving the year dot nc like year dot nc. Just very simple, okay? Because our data in daily, so I'm just sorry, the data is monthly. Just I'm converting the yearly. If you have the hourly data, you can uh, do the daily, daily to monthly, monthly to yearly. It's very simple, okay? Even if you have like half hourly data, if you want to make hourly data, you just sum two or average, like take two times everything in CDO. Just use CDO, okay? And follow this video. That's it. Any question?
Hello, Mr. Jalal.
Yes.
I've already downloaded Ubuntu,
Mm-hmm.
and I've already installed CDO on
Mm-hmm.
it.
Mm-hmm.
But whenever I want to access my data, I cannot be able to find it. I don't know. I don't know how
You didn't
to do it.
is what I'm doing. I'm doing if it is Windows, then use a CD, then space, then MNT. Okay,
Okay.
this not direct Ubuntu. So you need to follow
Oh, okay.
the Alexa.
All right.
You need to use the MNT. So I have
Okay.
tutorial. Uh, okay, Imdad, you can share the tutorial like climb. Every researcher should know the Linux in Research Society. We have it. So you'll find
All right.
how to change the like directory. Imdad, you can share the link. So any other questions? If no, we
Sir,
finish. Yes.
re-
Sorry.
sir, I don't understand clearly, sir. Could you please repeat?
Okay. Let me share my screen. I'm using VPN and using lot of things together, so it's making slow. Okay. In block you find the Linux basic commands, but we are making the tutorial. We are working on it. So we have this. Sorry, I'm using the Google Meet. It takes long time to open it. So here you just open our website, and in blog you will find the Linux basic commands every researcher should know. Okay, and here you will find how to change the directory. I'm using VPN, so it's making slow now. Okay, thank you so much, and thanks for joining.